In organic chemistry, we need to learn how one atom begins to bond to another atom. What's happening to the electrons that causes atoms, a carbon and an oxygen, to begin to stick together? So, this is a concept called hybridization. Let's jump right in. So we've seen the important elements in organic chemistry on the periodic table. We have our hydrogen with its 1s orbital, and we have carbon, nitrogen, oxygen, some of the halogens. Now the electron clouds on these start to bump into other atoms and they start to make bonds, and these atoms will stick together. So let's look at how the electrons mix together and start to make these bonds. So the first thing we want to look at is just the outermost electrons on some of these atoms. So for instance, hydrogen is just an s orbital on the outside, one s orbital. There's only one electron. Hydrogen is always that s orbital. But things like carbon, nitrogen, oxygen, now these have a second shell where they have an s orbital. So for carbon, I can have an s orbital and 3 different p orbitals on that carbon. And these point in different directions, up and down, left and right, and in and out. So on this carbon, on the second shell, there's the s orbital and these 3 p orbitals. And they're the second shell away. The outermost electrons are this s and p. Now these electrons, we don't need to think about them as tiny little particles that are flying around a nucleus, but they're also electron waves. And just like water waves, they can add together and subtract, and they can morph into different types of shapes. So this s orbital and these p orbitals can mix together. I can mix 2 of them together and call them sp hybrid orbitals. Hybrid just means mixing these orbitals on the same carbon atom. Or I can mix them with 1 of the s's and 2 of the p's and call them sp2. We just described how many of them we're mixing together. And if I mix all of them together, we call it sp3. So let's look at what these different ones look like. Let's take, for sp, I'm going to take 1 s orbital and 1 p orbital, and I'm going to mix them together. And because I mixed 2 of them, I'm going to make 2 orbitals when I'm done. And these orbitals will be called sp because I'm mixing 1 s and 1 p. And I'm going to make 2 of them, and when I have 2 negative electron clouds, the shape of an sp is like this, kind of an oblong kind of a shape. And if I make 2 of them and these negative electron clouds get as far away from each other as they can, they'll be about 180 degrees from each other. They'll point in opposite directions. So on this carbon atom, I can mix 1 of the s's and 1 of the p's and make 2 sps. Or, and this happens if I have a carbon atom that needs to stick to 2 different things. It'll make 2 sp hybrid orbitals. Or I can mix 1 s orbital and 2 of the p orbitals, p and p. Now these are on the same carbon atom. And when I hybridize those, we'll call these sp2 because that's what I'm mixing together. And since I'm mixing 3 of them together, we'll make 3 of them. 3 sp2 hybrid orbitals. And they're basically the same shape as the sps, but these are called sp2s. And when they get as far away from each other as they can, they're about 120 degrees away from each other. And this happens when my carbon needs to stick to 3 different things. When it needs room for 3 different things. Now it could be like a double bond on one side and a couple of single bonds. But when it has 3 different atoms it needs to stick to, it'll do this. And if I ever have a carbon atom that needs 4 things on it, this wedge means it's coming towards me, this dashed line means it's going away from me. And these can be whatever atoms, we don't care right now. But I need 4 things. So I'm going to mix 4 things together, an s and 3 p's. So my s and all 3 p's. So since I'm mixing 1, 2, 3, 4 things together, I need to make 4 sp3, we'll call them, because I'm mixing all of those together, orbitals. And when they get away from each other, they'll as far away from each other as they can, they end up in kind of a tetrahedral kind of a shape, where these are 109.5 degrees away from each other, tetrahedron. So the idea is if I need two things on my carbon, oxygen, nitrogen, or halogen, I'll make SPs. Two things, I'm only going to mix an S and a P. You always mix the S in with it. If I need three things, I'll take my S and two of the P's. And if I need four things, I'll take an S and all three of the P's. So always I have my S orbital and three P orbitals I can mix together. I can mix them together like this and make two SPs, my S and P to make two SPs. I can take my S and two of the P's to make three sp2s, three sp2s. Or I can take my S and all of the P's, mixing them together and make four sp3s. Those are my options. So I drew a few different bonding patterns. I just put these black spheres on here of atoms. It doesn't matter what the atom is. Now the things I'm going to count are, I'm going to count any atom stuck to my, any atom that's bonded to my atom I'm trying to investigate, or any invisible lone pairs of electrons, because they take up space too. They need to be in an orbital. So this carbon atom, if it's got two bonds attached to it, we say this is sp hybridized. I need two things, so I'm just going to mix an S and one of the P's to make two SPs. So this carbon atom would have two SPs on it. And these atoms would stick to those orbitals. This carbon, whether it's a single and a triple, I still only have two things attached to it. It's also going to be sp. Now all of these down here are similar. Here's a carbon with three things attached to it. It has a double bond and two single bonds, but three atoms. So if I need three things, I'm going to mix an S and two of my P's. So 1, 2, 3 things mixed together to make three sp2 hybrid orbitals. This oxygen atom, this oxygen here has an atom and an invisible lone pair of electrons and an invisible lone pair of electrons. So again, I count to three. 1, 2, 3 things. So I'm going to mix them and have an sp2, three sp2s around that oxygen. This nitrogen has 1, 2, 3 things attached to it. So atom, atom, lone pair, sp2. This carbon with a positive charge has three things on it, sp2, three things. If I have four things, whether they're four atoms, two atoms and two lone pairs, one atom and three lone pairs, three atoms and one lone pair, all of these have four things attached to the atom. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And if you need four things, I got to mix my S and all three P orbitals together to make four sp3s. So right now, I just want you to focus on whether it's two things, three things, and four things. If it's two things, that atom will be sp hybridized. Three things, it'll be sp2 hybridized. And four things, sp3 hybridized. So let's take a bigger molecule with a whole bunch of atoms in it, and let's see if we can go through all of the atoms and see what the hybridization would be. So I have all of these hydrogen atoms. Now hydrogens aren't hybridized, they're just s orbitals. There's only one s orbital on it, so there's no mixing allowed. All of these are just s orbitals. You have to have something bigger, like a carbon, oxygen, or a nitrogen, in order to have a second shell where the P's come in. But if it's just on the first shell, these are just 1s orbitals. They can't mix with anything else. That's what hydrogen always is. But all of the other atoms, there'll be some kind of mixing that will occur. Some hybridization. So let's just take one atom at a time, count 2, 3, or 4, and see what our hybridization would be. Let's start with this oxygen atom. So oxygen has atom, atom, lone pair, 1, 2, 3, 4 things. So I need to mix my S and all three P's This oxygen atom would be sp3 hybridized. I need all 4 of them to mix together. One sp3 orbital will stick towards this hydrogen, will point that way. One of the sp3s will point towards that carbon. One of them will have this invisible lone pair of electrons, and the other one has this invisible lone pair of electrons. This oxygen atom has one invisible lone pair, one invisible lone pair, and even though there's 2 lines here and it's a double bond, there's only one atom attached. Both of those bonds point directly at this atom. So I have 1 thing, 2 things, 3 things on that oxygen atom. So since there's 3 things on there, it's sp2 hybridized. One S and 2 P's makes 3 sp2s. One of the sp2 orbitals on that oxygen points towards that carbon. One has this invisible lone pair and one has this invisible lone pair. Now let's come down here and look at this carbon atom. This carbon atom has an atom, an atom, and an atom. 3 atoms. A single, and a double bond. But there's only 3 atoms and 0 lone pairs, so it's also sp2 hybridized. That's a 2 up here, sp2. This carbon has 4 bonds on it. This atom, 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 atom. So this carbon has a carbon, carbon, hydrogen, and nitrogen attached. 4 things. So it's sp3. This nitrogen will be hybridized. It has an atom, an atom, an atom, and a lone pair of electrons. 4 different things. 3 of them are physical things, and one's kind of an invisible pair of electrons. But they all take up space. 4 things, sp3. S and all 3 P's to make 4 sp3s. One of those sp3 orbitals points at that atom, one points at that atom, one points at that atom, and one is this invisible pair of electrons. All right, this carbon, 1, 2, 3, 4 things, sp3. This carbon atom has 1 atom, 1 atom, and 1 atom, sp2. This carbon atom, 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 0 lone pairs, is going to be sp2. This nitrogen has 1, 2, 3 atoms. Don't forget the lone pair. So that's 4 things. sp3 for that nitrogen. This carbon has 1, 2, 3 atoms, 0 lone pairs. So 3 atoms would be sp2. This nitrogen has an atom, and a lone pair. So that's 3 things. So sp2. I hope that introduction to hybridization was easy enough to understand. Right now, I just want you to get it's sp, sp2, or sp3. And in our next video, we'll learn how those orbitals start to overlap to make bonds between our atoms. Hey, click that like button, subscribe to the channel so you can help more people find these videos, so I can help more people and coach them up to be better at organic chemistry.